Hey, physics friends. I wanted to talk to you today about the Unit 6 test. You aren't going to be able to see me before you take that test on Thursday, so I wanted to make sure that you understand exactly what's going to be on it so you can prepare the best that you can. Let's get started. The first thing, there's going to be concepts. And what do I mean by concepts? This test is kind of broken into two pieces, fundamentally. There are projectiles, and there's circular motion. Inside of circular motion, it's either a horizontal circle, meaning that like a car is turning a corner, a person is turning a corner. You're swinging a rock above your head. There's a ball on a string. Some circle is happening horizontal, like perpendicular to gravity. Or it could be a vertical circle. You're going through a loop-de-loop. You have a ball on a string and you're swinging it in a vertical circle. There's a bucket with water and you're swinging it in a vertical circle. So this unit has got two main ideas, projectiles and circular motion. The concepts behind each of those, like with the projectile, a huge concept is that when projectiles move forward, they move forward at a constant speed. Projectiles move up and down. They move up and down, accelerating towards the center of Earth at 9.8 meters per second squared. Huge concept. When you're on flat ground, things are very symmetric. Like you can use the very top of the projectile, like the final velocity equal to 0. So that's a big concept. And you can double that. If you find the time, you can double that. In circular motion, the big concept is that something has to turn you. When you have a horizontal circle, something has to turn you. And then the turning force is the centripetal force. So something has to turn you. Typically, it's friction. If you've got a car going around a corner, friction is doing the turning. Like if you imagine a car going around a corner and then they hit ice, there's no friction. You don't make corners anymore. You just skid straight. Maybe some of you have experienced that. So friction is what's turning you. Sometime I talked about a rock on a string or a ball on a string. It's the force of the string that turns you. Maybe if you remember back a few weeks ago where we played that video game called Rubble, where you were maneuvering a spaceship, the thruster is what turned you. All this is to say is that something, the force of something is turning you. It could be friction, it could be a string, it could be your hand, it could be a thruster. Something has to be providing that circular motion. In a vertical circle, at the minimum speed, like a lot of times the question will say, what's the minimum speed you need to do to make a loop? Gravity turns you. So these are the big concepts going on inside of this chapter. In projectiles, you're going to get two problems very specifically. Number one, you're going to get a flat, where you launch something on flat ground, and you'll also get something where you launch from an elevated position. What's unique about flat ground is you can use this spot right here, that the final velocity is equal to 0. And then you can find the time it takes to get there, and then you just double it. And that's the whole time it's in the air for. So this is the secret to flat ground problems. This does not work with elevated. If you find the time it takes to get to right here, doubling it only gets you right there. That's not helpful when doing an elevated problem. Remember, in both of these problems, the first order of business is we break these into their vertical and their horizontal components. Horizontally, there is no acceleration, so you just have velocity, distance, and time. Vertically, there is acceleration, so there's an initial acceleration, distance, and time. The first order of business always is when you launch this thing, you need to find the x component and you need to find the y component. The x component will always be the horizontal. So whatever you find for this x, that's going to be the horizontal. Whatever you find for the y, that's going to be the vertical. Do not, I repeat this, I can't repeat this enough, do not put the final velocity equal to 0 here. It is actually moving down when it hits the ground. Final velocity is not equal to 0. This is wrong, 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 and you'll get it wrong on the test if you continue to do that. The acceleration is always negative 9.8, assuming that up is positive. You're just, it may give you the distance, but if they tell you how tall that is, how tall it is the vertical. So you'll put that in there. You'll end up most likely solving for time. And when you use this distance, that is the same. You don't have to double it or anything, because when you're using this displacement, that's the whole time that this was in the air. So there you have it, kids. That's what to expect on the test coming up tomorrow, the next time you see me. There'll be concepts. There will be 2 projectile problems you'll have from flat ground and you'll have from an elevated position. And then you'll have maybe 2 circular motion problems, maybe one where there's friction, maybe one where there's string. And then you'll have a loop-to-loop problem where you set gravity equal to the centripetal force.